We are a go. Hey, how you doing, everybody? We are on episode 3 of our AppStream. My name is Hansel. I'm the founder and CEO of the Coder School. I'm here with my man, Wayne.
I'm Wayne. I'm here with Hansel. And yeah, episode 3. Really, I couldn't believe episode 2, so this is even harder to believe, actually.
That's right. We barely got by episode 2. Now we're on episode 3. So we're here to entertain you guys and teach you guys a little bit, and then jump into also teaching you how to make an app. Now, this episode is actually for a little bit more advanced, I would say. We're going to jump into some logic where you really have to think about it a little bit. But for those of you who are beginner coders, you can still follow along with us by just sort of copying some of the code, and you can change it around to kind of play around with it that way. So for some of you older kids, feel free to stick around. We are going to use Scratch. We're going to show you some Python and JavaScript as well. So for some of you older kids, it might be pretty cool for you guys as well. So what we're going to do is what we always do. We're going to start off with a technical talk, what we call our tech talks.
Tech talk. What's that short for? What's that short for?
A technical talkamajig.
Right, that's right. A technical talkamajig, and it's short and it's catchy and it's called Tech Talk. I think in episode 1 we kind of introduced it like that.
Yeah.
Kind of interesting.
So first, a quick shout out to our backgrounds. We always like to do this. I'm sitting down here. This is our Sarasota, Florida location. Shout out to Allison, Pete, and the crew out there. Wayne, where are you at, man?
La Jolla, beautiful San Diego. If you just stepped outside the door, I'd be in La Jolla. If you could really be in this picture, that's where the picture's from.
I'm sure it's sunny down there. So shout out to the few shout out to the people in Florida. Did you guys see that glitch? It was actually just a glitch of the video, not me.
That's a Facebook Live issue.
All right, let's get going. So Tech Talk. So today we are going to talk about something that we do in our schools, which is teaching kids how to code. We're going to talk about languages. We're going to talk about the differences between a couple of languages. Wayne, you and I are wearing matching outfits here, a little bit dorky.
Yeah, well, matching logos, but I have the hoodie. I'm cool.
Nice. Hoodie. Do the super cool coder hoodie thing. Yeah, I'm not as cool today.
I'll look like the Unabomber, but yeah, it'll mess up my hair. My hair is getting so long now. If I wear a hat, man, it is like hat head.
That's why you guys shave it all off.
Yeah, or I'm just gonna go beanie, maybe beanie. Episode 4, beanie.
Episode 4 is beanie episode, so stay tuned for that one.
Stay tuned. You will not want to miss that.
Languages. What are we doing here? So at the Coder School, what we do is we teach kids how to code, but we teach them in a very customized way. Meaning, like, we can kind of teach kids all kinds of different stuff depending on their level. But what we found is a lot of kids end up doing the same kind of stuff. Now, I don't want this AppStream to start sounding like a marketing thing, so we're not going to talk about that too much. What we're going to do is we're going to talk about the language.
No marketing
at all, even though like we're like right in our schools and we have our logos everywhere.
That's true, but that's subliminal. That's subliminal.
Subliminal marketing is okay. So, all right, so the languages we're going to talk about Scratch and other block languages like that. We're going to talk about JavaScript. We're going to talk about Python and tiny bit about Java. So Wayne, why don't you kick it off? Wayne is our master curriculum operations guy. So he has it all up in his head.
Yeah, so I mean,
Wayne, what does Scratch stand for?
Scratch stands for, well, you know, I don't know. Have you ever had an itch to code? So, well, Scratch, it was invented by MIT, which we all aspire to have gone there, or if you're young, you want to go there. It's an awesome school, but they created this amazing drag and drop language, as Hansel said. So I think, you know, a couple of the key characteristics of this language are that it's drag and drop. So you're not dealing with, you know, if you're younger and you're not the best typer, don't worry about it. You can handle Scratch, no problem at all. And it also, by doing that, it eliminates all the syntax and things that you might be worried about in some of the other languages. And so you're really just focused on what's, you know, going on in your mind, the logic, and trying to solve the problem and what you're trying to build. And so it's beautiful. You can just drag and drop, you know, it's almost like Legos with logic on it in your computer.
Yeah, and you guys probably all know this stuff already. So, but you know, we're going to we're going to do our most of our code today because it's going to be done in Scratch. The coolest thing about it is that you can build something really graphical and fun really fast, like in about an hour, right? So that's why we use it. That's why in our AppStream we can use it so fast. I thought about doing Python and JavaScript, but I just can't type that fast. So, all right. So Wayne, what about language number 2? So let's say after elementary school, some of these kids who are, what would you say, 9, 10 years old?
Yeah,
what would they do
that's the
next?
perfect range, right around there, 9 or 10. So if you've been learning to code and you probably started off in Scratch for the reasons that we just talked about, then you're probably starting to move into something like a JavaScript when you're around 9 or 10. It's going to be JavaScript or Python, but maybe we can talk about JavaScript first, because either or are perfect first languages, first typed languages to get into after Scratch. And so JavaScript, the first one that I'll just talk about, it's known for being the language of the web, because it's the only language that actually can run in your browser. And so all the websites, so just think about that. Everybody lives on browsers, and all the websites that you've ever been to, they're all running JavaScript. So, you know, just think of JavaScript as the web, and that's what it's famous for. It's also it's an easier language to understand. So there are harder ones. So JavaScript is known for being, you know, pretty easy to read, being the language of the web. And also it kind of is always married together with HTML and CSS. Those are kind of the 3 things that go together to build your web pages.
So I'm being your dictation machine here, Wayne. I'm typing out all your notes for you. I'll be your
Nice.
admin for now.
I'm pointing at the screen. Those are perfect.
I can tell.
Yeah. So yeah, I mean, anything else to add? I know you do tons of JavaScript, Hansel. I know you've even, like, in our recent, you know, going remote, been building tools left and right and things like that.
The main thing I have to add is the reason why I think JavaScript is so cool is because it runs on all browsers. If you make JavaScript, that means pretty much everybody in the world can run it pretty easily, because everybody has a browser. So that's why I think it's pretty cool that if you're able to be an expert in JavaScript, what they call a full stack developer, that's one of the part of the stacks. It's actually a pretty cool language to learn. So, yeah. Okay, so that's JavaScript. What else?
So the other one that I think it seems to be very popular these days is Python. Now everybody, you know, yeah, it is like a buzzword now. It's so popular. I think that there's so many job postings out there looking for a Python programmer and things like that. So, you know, lots of enterprise companies are using it, you know, to power their applications. Funny little thing, I mean, it's actually didn't get its name based off of the snake. It got it from a comedy team called Monty Python back in the 60s, which was really funny. Yeah,
I didn't know that.
That's where it really came from. Yeah, so just kind of a funny thing. And if, you know, none of you are, you know, old enough to remember Monty Python, but you could dig up some of their stuff in the archives. They are very funny. They did a lot of funny movies. They started off as like a comedy skit, but that's where they came up with the name, which is pretty.
So is the language also quite hilarious?
The language is quite hilarious, or just appreciative, I would say.
Dude, I keyed that up for you so well.
Yeah, so if you're not laughing already, but in all seriousness, it's known for being very, so if I said JavaScript was somewhat human readable, Python is most famous for being even more human readable. So when we look at a couple code snippets from it, you'll see Python is actually almost like you're reading just a sentence. It has the least amount of syntactical, you know, gotchas and things. So it doesn't even use semicolons. So that's one huge
Which
thing.
Is crazy.
That is, if you're a real coder and you've dealt with all the other languages, semicolons is kind of like, there's no language without it. But then here comes Python and says, but
it does use a lot of colons.
Yeah, a lot of colons. So, you know, it can, you know, there's a joke there for you somewhere, Hansel. I'm not sure where you're going with that. But,
a colon joke? All right. Well, what bathroom jokes for episode 2? Now we're going to move on to different kind of jokes.
That's true. We're going to go into grammar. We'll do a grammar joke about colons.
All right. So the last language we're going to jump into is, let's just talk a little bit about Java then.
Yeah. So let's see. Java, interestingly, let's see. That one came out around, I think 1990 or so.
Wow, good trivia bit.
Yeah, a little bit. So most of you weren't born. Unfortunately, I guess we were born. But
Who invented Java?
Sun, a company.
Does anybody remember Sun Microsystems?
Yeah, if you remember Sun Microsystems, you're old like us. But there was a company, they invented, and then Oracle, which buys everything, eventually bought Sun, and so they own Java now. But it's a more complex language, much more complex, much more difficult to. It's not as human readable. So if you look at Java code, a lot of times you'd look at it and not intuitively be able to figure out what it's doing. And if you're writing Java code, you're very likely going to have a syntactical or a typo, or missing a semicolon, missing a paren. And even though you've got the logic perfect in your head, if you're missing one of those little things, it's going to be very frustrating because it needs to be perfect. And it's much. And
the other thing though is for all you kids who are a little bit older, and for all you parents out there, you guys probably know that right now AP Computer Science is based on Java, uses Java. So that's one of the biggest reasons why we teach a lot of it. A lot of our high schoolers will come in asking for extra help, and we will teach them Java so that they can get an A++ on their AP Computer Science.
That's right. That's right.
So there you go. That's what it is. So if you guys see the language, I mean, it's not like there's only 4 languages in the world.
Oh yeah, not at all. Not at all.
A million languages. There's so many of them out there. These are the ones we typically focus on because these are the bigger ones that folks tend to use more, and some of them are just very easy to sort of teach with. It's worth noting though, for all you kids out there who are trying to move from scratch into your next level, a typed out language like JavaScript or Python, it is pretty hard. It is very different. You guys know with Scratch, it's just drag this, drag that. With JavaScript or Python, you have to type everything out. And after you type it out, you have to type everything else out. And then after that, you got to type more out. So before you get stuff on the screen and moving and games and stuff like that, you got to type a lot. But once you're done typing, it runs pretty fast and it's pretty smooth, but it takes a lot of work because they're pretty powerful languages.
Yeah.
So
don't get And don't get too caught up in any particular language. They all use the same logic. The logic. Learn to think like a coder, and it doesn't matter what language you're using. There might be languages that haven't been invented yet, and if you know the logic, you're going to be a rock star.
I'm pointing at you, Wayne. Should we do a virtual high five for that one?
Oh yeah. Fist pump. Oh, you just wrapped my fist. Okay. Oh wait, you know what? I'm not going to the camera. You know where I was going? I was putting my fist actually to the screen, thinking like that was going to do that. And now, see,
you're so high tech.
The camera is not your screen. There you go. Lessons learned.
That is a fist bump because that is so true. And you guys will see once we get to the end of the Scratch app that we're making for you guys. It's really not about like knowing what blocks are in Scratch. It really doesn't matter if you know what the blocks are. What really matters is that you understand the logic, because when you understand it in one language, it's probably going to be really, really close in another language. Coding is not about knowing these blocks. It's not about knowing commands. It's not about knowing what to type. It's about the logic. It's about thinking through the logic. That's why we think it's so important for a lot of kids to learn. It really helps you step by step think through things. So cool. So that's our tech talk. For today, I'm gonna now start the coding. So now you guys can wake back up.
Gonna get to the good stuff.
The good stuff. Now
coding.
I will share. What should I share? I will share my Google Chrome. All right. Am I sharing anything weird here?
No. Yeah, I was like, those are your family photos, Hansel, and are only wearing a towel.
That's good. That's good. Okay. So here is Scratch, guys. We are going to build an app today that will, since we are still in this COVID crisis, we are still doing a little bit of COVID stuff. So today we're going to do something that emulates flattening the curve. So the curve itself is actually kind of hard to draw, and that's a lot of the logic, which will be kind of interesting. We're going to have this curve kind of come down, and then as the game player, you are going to pretend you're a scientist, and you have to solve problems super fast in order to squash the curve. So I'm actually going to demo it for you first real quick. Wait a minute. How do I do that? Oh, I better sign in. So I'm on Scratch here. So we're going to go a little bit faster this time because this AppStream is for a little bit more intermediate, beginner to intermediate folks. So if you need to take a break, you can always hit pause and rewind and see where we're going. So
And we'll freeze just like this for you if you hit pause. Somebody hit pause. Somebody hit pause. Okay.
Unpause.
Unpause us, please.
All right. So we're going to show you. I'm going to show you here real quick. I hope this thing works. Yes. Here's my curve. See how my curve is getting bigger and bigger? This is the line where if you hit the line, then you lose. So that's basically what you need to do is you need to answer these questions as fast as you can. Oh my gosh, I'm already losing.
Better get it. 14, 7, 8.
My math is. You yell it out and I'll type it,
13, man. 8, 16.
Look, see how I'm flattening the curve, guys?
10. Oh,
it's getting so low. 8. And every time it changes color too.
16.
See, so I'm flattening the curve. So that's what this game is about. If I don't answer anything, you'll see that just like the coronavirus, the curve might start popping higher and higher if we don't do anything about it. And so what happens if it goes all the way to the top and it gets to that red line? Red is bad. Oh, you lose. So that's what this game is about. That's what we're going to code. You guys will see that this curve actually is kind of a curve. It kind of curves up and curves down.
Right.
A little bit of a stair
step. A little jaggedy, but as Hansel said, I mean, it's hard to program it perfectly smooth. That might be a whole nother lesson, but it's still curving, but a jaggedy curve.
Jaggedy curve, especially because we are here trying to teach you guys in an hour. It can be done, and you guys actually, we challenge you to do it, but we're going to do the jaggedy version just so you guys see, so we can get through it in an hour. All right, so here we go. So let's start with a brand new project. So we're going to take this cat first, and we're going to change it to a dot. We're going to use this pen functionality instead, and have it draw behind them, and because cats don't really leave a trail behind them usually.
Sometimes they do.
Sometimes they do. Back to the bathroom humor.
Sometimes they do.
Sometimes they do. All right, so we're gonna take this cat. Let's go to costumes and let's just make a new guy. So go down here, hit paint. We're just gonna do a tiny little circle here. And then we can delete these guys. We don't need the cats. So your main sprite's just gonna be this dot. All right, so let's go back to the code. So with the code, what do we want to do? So we're gonna try to make the curve first here, guys. So we're gonna start it pretty easy, but after a while, you'll have to kind of dig into the logic a little bit. So for now, I guess follow along and see if you understand what I'm doing here. So I'm gonna put a forever loop in here. I'm gonna, actually, let's see, sorry. I'm gonna start off when green flag clicked. We always like to click the green flag, so.
Yeah.
And what I wanna do here is I'm trying to draw this guy going from left side of the screen to the right side of the screen, because eventually we're gonna have him, make a little curve inside, right? So,
yeah, but first, right, you gotta find the bottom left corner, where to start from.
That's right. Actually, I don't even know typically, how would you do that, Wayne? Would you just drag your guy there and look?
I would drag my guy there, or there's that cool little thing under backdrops. You could go grab that grid backdrop. That actually is pretty cool. You could just grab that.
Oh, the grid. Yeah. Okay. That's too many clicks for me, man. I'm a
all right. Guy. But you're right. You can just grab that dot and put it where you want to start. And
okay. So let's just say we're going to start it here. So it actually fills this out for you. Go to so negative 235 and minus 123 in the Cartesian coordinate system.
Yeah. X, Y,
Wayne, a trivia question. Who is the Cartesian coordinate system named after?
Mr. Ding. Cartesian. The Kim Kardashian. Kim Kardashian.
That's right, Kim Kardashian.
I think so.
That's right. There was a famous show about
it was her father.
Back in the 1800s. Yeah. All right, I'm pretty sure it was named after Rene Descartes, who was a famous mathematician way back in the day, Cartesian coordinates. So Cartesian coordinates just basically means, X is everything going from left to right, and Y is everything up and down. Wayne is doing the Ultraman thing.
Yeah.
Ultraman.
I'm protected. I'm safe.
All right. So forever. Okay. Let's stop dilly-dallying and do some coding.
Yeah. Let's get there.
Okay. So we want to go all the way here when we first click the green. flag, and then we are just going to change x by 10 forever. Actually, maybe not forever. Should we do it forever? No, we should not do it forever. We're going to go repeat until, ooh. You can tell this is more difficult because I'm have to think through it. Where's my
Thinking
repeat?
like a coder. Thinking like a coder.
Thinking like a coder. That's very important. Okay.
Well,
so
you're going to keep doing it, right? And then until you either hit the red line or
yeah. So this time I'm going to start off very easy. We're just going to go until we touch the edge. So
good call.
All right. This is pretty easy to read, right? What's it going to do? It's going to go here first, and it's going to keep going, change x by 10. And Mr. Descartes says every time you change x by 10, you're going to move over a little bit, right? So this guy should
so notice, yeah, the y. So the y is not changing. So you're going to just not go up or down. Just go to the right.
Oh, oopsie! I'm already touching the edge. That's why I didn't do anything, right? So
that is why.
In a little bit by saying go to -230. So if you guys have that, your ball might be a little bit different size. So I'm going to start it at 230, but just make sure your ball is inside the screen and it should work. There you go. Boom.
Oh, there you go. And then
so this is a dot that's not leaving any kind of poop trails or any kind of trails right now. We got to have some trails.
And if you look at your screen here on the bottom, you can see he went to x equals 240. So we went from negative.
Where are you pointing, Wayne?
Yeah, I'm pointing in the below your canvas, I guess, below where it runs. You know, where it shows the edge,
here.
right?
Here, is this where you're pointing?
Yep, exactly, right there.
Cool. Yep. That shows you exactly what your x and y's are. Good point.
Yeah.
Okay, so now we're going to drag a little line behind him. And so what we need to do is I actually have a pen here already. You guys might not. This is actually a new type of code block, which you can use. To do that, click on the code area, add extension down here. Then the pen is an extension. Look at all these other things too. You guys can play around with all these other things. Makey, oh, I didn't know that. Translate, look at that. You can translate into, wow.
That's cool. Remember, ni hao ma.
Oh, I remember ni hao ma. Okay, so we're going to pick the pen. So what the pen does, it lets you draw wherever your sprite is. So you can see all these new code blocks here. Some of these will help us today in doing this drawing. So the first thing we want to do is, I'll just show you right away. You might run into this issue, but you want to go to this point, and then right after that, you want to erase everything that was drawn before it. Otherwise, you'll have squiggly lines all over the place.
Yeah, every time you play the game, you'd make a mess, and it'll be just messier and messier. Got to clean up after yourself.
That's right. It's like clean up your room. So this is a one line code to clean up your room. So it erases the entire screen, and then puts the pen down. When it puts the pen down, what does that mean? It means it puts the pen down, and then just wherever the guy goes, it'll leave a pen trail behind him. So I'm thinking this should work. Let's hit the green flag, and there you go. So line straight across. So that's pretty easy. The curve is so flat. We are such winners. Hopefully this is what it'll look like in some short amount of time.
Yeah, hopefully sooner the better.
Sooner the better. All right, so that's pretty easy. That's way too easy for you intermediate folks. So what we want to do now is actually draw the curve. And if you guys can think about how, so the one thing I want to make sure is important to say is for you young kids, you can definitely draw, drag in the code just like I'm doing, but the important thing is understand why it's being done. Dragging in code isn't really coding. If you're just copying what somebody else is doing, you're not really coding. You're just sort of copying what somebody else is doing. It's like if you took somebody else's book and you just wrote down all the same words, then you didn't really write a book, you just copied his book, right? So for coding, the reason why it's so important to understand what this is doing is that you're not always going to want to draw a curve, right? Maybe the next time you're going to want to draw a circle or something, I don't know, a spiral or whatever you want to do. In those cases, you have to know the logic and how to put everything together. So as I'm going through this, please also try to understand why we're doing this, why each command is put where it is, and instead of just drawing it there, or dragging it there.
Yeah, and I mean, if you're not following right away, I mean, sometimes, you can kind of start with a copy of it, but then as you are using it, the key is to get to the point where you do understand it. And that's the only way you could ever change it up. That's not to say that almost every coder hasn't copied code to start with, But
That's
the
right.
fact that they're able to tweak it then to do what they want to do, that meant that they understood it. So it's okay to copy code, but you just got to understand it.
That is such a good point. There's a lot of programs out there that are bajillion lines long, but a lot of the times the coders are copying chunks of code in, but once they copy it in, they change it to do what they want it to do. So that's very, very common. In fact, almost every coder does that. It's just almost
Right.
the only way to code.
Almost everybody copies some code, but then they tweak it. Yeah.
Yeah. All right, so now now that it's going straight across, we need to change the Y as well. So we want it to go up and down. So first, I'll just show you guys that, first of all, Y going this way, is that positive or negative? Well, I guess we can just answer that. It's negative.
Yeah.
I'll just show you quick. The real quick way is to just do it. So I'm going to put -10 here, hit the button. Wait, I'm totally wrong. Is it positive?
It's positive. Yeah. It should be positive.
I should have tried it first.
Yeah,
Now I look the fool. Now I look
But,
like I don't know what I'm doing.
But you're actually just such a good actor, Hansel, because you really pulled that off. That was the lesson that he was trying to teach you kids.
That's right. It's only a lesson. Totally a test.
He's a professional actor. He's a professional actor. He did that really, really well.
Okay, now if I do +10, is that going to work?
Yeah.
Okay.
Okay.
All right. So you see guys how it's a stair step. So why is it a stair step? Because the pen is actually following it, right? We're going x10 this way, x10 that way, 10 this way, 10 that way, 10 this way, 10 that way, and the pen just follows wherever the sprite goes. That's why it goes straight up this way. Now what we need to do is we need to have it go up and down. This is where it gets a little bit more complicated. So we're gonna throw in a little bit of physics to you. A lot of games that you guys would play has a little bit of physics feel to it, right? So I don't know, like Mario, any kind of platformer, like a Mario Brother thing, Pokemon. What happens is that these, if you have a ball kind of go up and down like that, you know, kind of slow down and come down really fast, that is gravity. We're gonna kind of use a similar formula here. We're gonna dig into gravity, I think, in our next AppStream. But for now, we're gonna use a similar formula. So what we want to do is actually, we want it to go up by a certain amount and then over by the same amount, 10. Let's just say X is always going to be 10. And then we want it to go up by less amount and go over by 10. And then go up by less amount and go over by 10, less amount, less amount, less amount, until we go up by 0. And then we start going down. In other words, going negative. So I hope that kind of makes sense. We'll start putting the code in here. What we need to do that is we need to create a variable.
My variable.
My variable. That's pretty generic name. So this is going to be the change in height, I guess, is what we're going to call it. So this, sometimes people who are awesome coders might call this delta, but we're going to call this change in height. So rename the variable, right click, rename the variable. We're going to call it change in height, so we all know exactly what that means. Is also known as delta, which is kind of like a cool way of saying change in.
Yeah, or like if you're in Tom Cruise's the Air Force or the Top Gun, Delta would be a cool name. That'd be my
that'd be your call sign.
That'd be my call sign. Delta.
I'm gonna call you Delta from now on. You be Delta.
That's right. I'm Delta.
Okay, so change in height, we're gonna say, let's see. So first we have to set it. So the change in height, we're just gonna start it off up here, and change in height, we're gonna call it 10. Let's see, I don't see my camera. Where's my camera? I can't tell what I'm doing. Here we go. So 10 means, so if you 10 means, well, let me add in the code first. We are going to change Y by change in height. Hoya. So what happens is down at the bottom here, it will go up by 10, and also X will go over by 10. And the next time we want it to go up by 9. So we want it to go up by 10, then up by 9. Actually, the video is not doing me justice. I'm going to do it here. We want it to go up by 10, then up by 9, then up by 8, then up by 7, all the way until it gets to 0. And then we want to go up by -1. What does up by -1 mean? Down, right?
Down, yeah, exactly.
So what that will do is basically it will make it look like it is a ball that's kind of going up in the air and coming back down. If you throw a ball up in the air right now, you'll notice that it goes pretty fast and then it slows down at the top and then it comes down and starts going really fast. That's what this is going to look like. That's what this should look like.
You would make Sir Isaac Newton proud.
That's right. That's right. Sir Isaac Newton. I should have made that thing into an apple.
Well,
so change
too late
y
now.
by blah, blah, blah. Too late now. Yeah. So as soon as we change y by change in height, we are going to change our change in height. Right? We are going to change it by -1.
Yeah, we got to make it less. So the next time around, it will be, like you said, 9.
That's right. It won't go up as high, and eventually it'll go down to 0. Let's just see what happens right here. Woo, look at that.
Ooh.
But look at that curvature. Doesn't it look like I threw a ball and it just kind of went, woo. So that's actually how physics kind of works in some of these games, right? You kind of change how much you change. And in fact, that's how physics works in real life. You change how much up you go every second or whatever. Okay, so that's what happens there. So we got our little curve going. Now, all right, so Wayne, let me quiz you since you're the only other guy on the call.
That's right.
How do I make this curve go higher? What's the fastest way to do that right now?
To make the curve go a little bit higher, you've got to I mean, you could start your delta higher, right?
That's right. So think about if you're home and you're throwing the ball and you throw it up kind of lightly. That means the speed just leaving your hand is not that high. If you throw it really hard, the speed that's leaving your hand is higher. So that's basically what the delta is. This is almost kind of like speed it's leaving your hand. So
yeah, this is like Peyton Manning throwing in the Super Bowl 50 when he was kind of old. But if you look at footage when he was younger,
that's right.
The ball goes and it starts off much, higher.
Ball goes. Super Bowl 50 was maybe his last hurrah, where it was kind of more like this trajectory.
Yeah.
But if we change this thing to 30,
oh yeah, 30. Let's try
Whoa!
it.
It just hits the top edge, and then it stops, of course, because we have touching edge.
That looks awesome, though. That's a good big throw. Big throw.
So let's see. 20. There we go. That's Peyton Manning back in the day.
That's touchdown. Touchdown. Yeah.
That's right. Wayne and I are Peyton Manning fans. So Peyton, if you're watching, what's up?
What's up?
Okay, so that's how you change the curvature. So what we want to do is, let's see.
But we did drive by his house and try to, get him to come outside. Peyton, you did not come out and say hi. Why not? Why not?
I should show that picture right now. That would be funny.
Yeah.
Okay, so here's what we're gonna do though. So that's basically how we're gonna emulate the curve. That's pretty close to how we're gonna do it. There are better ways, but this is the sort of quickest way. Let's put a loop around this thing so that we can do multiple loops. So what we wanted to do is go up here, then have a smaller and smaller and smaller and smaller curve. So let's put a, I think we're gonna put a forever loop in here this time. Well, yeah, let's just start with a forever loop. So if we keep doing this, what's it gonna do? I guess that's not really gonna do much. That's not really gonna do much. I want it to go forever. I want it to change the, I wanna start the height. So this, you know how Wayne said that we wanna start the height at 20, that makes a bigger throw, a higher throw. We wanna change that height every time we run this curve. We're gonna clear the screen and draw another curve with a slightly lower height, right? So how do we do that? So again, guys, if you wanna think through the logic, this is a great time to hit pause and see if you can figure it out yourself before we end up doing it here. So, okay, so we are gonna create a new variable. This new variable, make a variable, is going to have to track how high each curve is gonna be. So we're gonna call it initial height.
Ah, good name, good name.
Yes, initial height. So we always know what that thing's gonna do. Initial height is going to be, we're gonna set it here way up top. We're gonna set it to, let's say 20, I guess. No, we're gonna set it to 10, and eventually we want it to get it to 20 because we're gonna go higher and higher. So set change in height delta to, oops. I'm changing, I'm gonna set the initial height to 10.
Oh, right.
And actually I could also set this to 10, but if it's good programming practice, what would I do?
You would just drag the initial height into there
That's right. That's good
Yeah.
programming practice. And the reason is we can always change this 10 in one place only, and we don't have to change it again here. That's why it's good programming practice. So we start the initial height at 10. We're going to set the change in height to 10, I guess.
Yeah.
And then we are going to go in here and we're going to do this forever loop. Wait a second. The forever loop, we always have to erase it first and then pen down. And in fact, sorry if I'm going a little bit fast, guys, but you guys can see that what we want to do is set our initial variables, and then we want to go forever and we want to go back to the starting point here. We want to erase the entire screen and then put our pen down again so that there aren't any weird lines anywhere. So we're going to put that pen down again, and then we're going to keep going until we touch the edge and do this code to draw the curve. Now at the end of that, what we need to do is we need to change at the end of drawing this curve, which ends right here, we are going to need to change oops, we're not going to need to change it. Oh yeah, we are. We're going to need to change our change in height by, we're going to change it by, let's see.
You want it to go up a little bit, right?
We want it to go up a little bit, right? So we want to set it to, I guess we can change it by 2.
Change it by 2 or something, yeah.
Yeah, change that. So now that we have a different change in height, we're going to go back up here and, oh wait, we can't set the change in height. Oh, okay, that's what's faking me out. Because our change in height is already all messed up here because we've been changing it. So it's going to be a different value. That's why we need the initial height.
That's why, yeah.
All right, so now we need to reset. So when we're done with our loop, we're going to set our change. We're going to set our change in height to initial height.
To start it over.
To start it over. But we're going to change our initial height by 2. So now the next time we run here, initial height will be 12. And then we reset the change in height, the delta, to 12.
Yeah.
And then we come up here, and we go back to the start, and we do it again.
Yeah, and it'll keep going higher.
Should keep going higher. That's what we think.
In theory, that's what I would think at this point.
Let's try it. Boom, boom, boom.
Going higher.
Is it getting higher? It's like Peyton Manning is going backwards in age.
That's right. It's getting stronger. It's getting stronger. And that one.
All right, so now it's going to keep going because it keeps hitting the edge.
Oh yeah. Now it's just going bonkers.
Now it's going bonkers. All right, so so now I think that is pretty much what we want to do in terms of the curve. So now we have the curve going up. We could probably, well, I think we can just leave it like that. So that is a very rudimentary curve, as you can see. One of the challenges for you intermediate coders is to make this curve much more smooth, number one, and number two, not have it go flying down as fast. Like you can see that this curve is kind of not flattening out. It just keeps diving straight down. We wanted to kind of take a gradual flattening. Now, if you could code that, then you would be a stud. That is actually pretty hard to code. Takes a lot of logic thinking. It's actually not a lot of code, but it takes a lot of logical thinking. We'll leave this part as this curve here for now, like that. What we're going to do now, though, is create the line so that we can start asking the questions, so you can, start typing away and try to beat the curve.
And try to beat the curve.
That's
beat
right.
the curve.
So, beat the curve. That's what this game is about. Let's rename the sprite so we know what it is. Or
Ball A.
Ball A. Everything is Ball A. That's going to be my call sign, Ball A.
Ball A.
All right, we're calling this guy the curve.
Goose and Ball A.
Goose and Ball A. That's right, Top Gun. Oh, I wonder if they're going to release Top Gun this summer. That's going to be
true. That's going to be interesting. But that was big movie news before all this.
Okay, so we are going to create another sprite. We are going to draw this guy. So go up to Paint, and it is actually just going to be. We always like to use red because red is bad. Bird.
And we tend to like to use those weird voices for some reason too.
It sounds like a sheep.
Bird. Bad. Red.
All right, so I'm just gonna draw a line here. That's just gonna be our line. See, it pops up right there. And let's go to the code. And now we can drag this line around. It should be draggable. We'll just drag it pretty high to the top. So when it hits that top, game over. Now, what's this guy going to do? This guy is going to ask you some questions. This is we're going to do some random questions.
So, hey, one thing. So actually, when you drag the red line just right to the edge, are you just going to let the logic of when it touches the edge, it's over? Because it's pretty much the red line is the edge. Or would you code it specifically? Like if you dragged it lower, you'd have to code it specifically that when it touched red or something.
Yeah, so basically that's what we're gonna have to do. We're gonna, in order to check if the game's over, we're gonna check if the ball is touching this line. So when it hits the edge, it's gonna draw another curve, or at least these edges.
That's right. So you are gonna have to put that test. That's right.
It should never hit the top edge because it'll hit this line first. So so this line, we're gonna put some. We're gonna call this the line. Yeah, okay, so we're gonna call this the line, and the line is actually, even though lines can't usually talk, this one's gonna be smart, and this is gonna be asking you the questions. It's gonna be asking you, and you are gonna pretend to be the scientist who calculates these things super fast so that you can flatten the curve.
That's right.
In the sensing area, we are going to ask, and again, we're gonna do this as soon as the green flag is clicked. Where's the green flag? So we're gonna ask, what's your name and weight? No, we're not. That makes no sense.
Yeah, that makes no sense. That is not a scientific question.
Okay, so what we're gonna do is we're gonna create two variables completely randomly, and we're gonna ask you to add those two together. So I'll just do this for you pretty quick. So we're just gonna go into variables. We're gonna make two more variables, one called number1, and we're gonna make another variable, one called number2.
Oh, you're about to say it, number2.
That's right.
I got you.
Cannot get away from that. Number2.
You cannot get away from it, Hansel.
I'm gonna make a number1, and then I'm gonna make a number2.
Yeah. Sorry about that. I apologize. We
digress. Never apologize for bathroom humor. Yeah. Okay, so what we're gonna do is we're gonna ask you to say what is number1 times number2. But first, we're gonna set number1 and 2 to a random number.
Random number.
Right, so that's important because we want to make sure we don't give the game away.
That's right. You want different questions every time.
That's right.
And you want them to be random. Yep, random.
So if we hit operators, we can do pick random number from 1 to 10. I'm not very smart with my math, so we're gonna go 1 to 10.
Yeah.
It should be pretty easy. Should be able to type that pretty fast.
So we don't hit the red line. We don't want to hit the red line.
We don't want to hit the red line. All right, so number 1 and 2. So we want to say something else in here. We want to say what is num1 times num2, but that looks pretty lame. What we really want to do is we want to put the actual numbers in there.
Yeah.
So Scratch is not super awesome with that, but it still works. We are going to join with a join and a join and a join. So what join does is, of course, it joins two text strings together. They call these text things strings. So we're going to say what is, and we're going to put that right in here. What is banana? Should we just say what is banana?
What is banana?
Wait, we want to say what is.
Yeah, you should put in bread on one and banana on the other. Banana bread.
Ah, that's easier than actually making banana bread.
I know.
I wonder if we can do that. All right, so what is, we gotta have to do another join in here. We're gonna say what is join in a join. So what is number1? Now we need to be able to say plus number2.
Plus, so another join.
Dang, that's 3 joins. Join, join, join. We need a join, join, join.
Join, join, join. They need a join, join, join.
Official command. Join, join, join.
Yeah.
Keep saying join, 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 join. Doesn't that word sound really weird?
Sounding like it's not even a word anymore.
Yeah, join, 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 join. Okay, Matt. Okay, Wayne, you keep saying join while I do the code.
Join, 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 join.
Now, who out there is annoyed? Okay, we're gonna say plus. Awesome, awesome. Okay, so we're gonna say number1 plus number2. Okay. What is number1 plus number2? And wait, so well, let's just let's just click this real quick just to make sure it works, okay? I'm gonna break it off here and just click it. So you can see right here what is 5 plus
Oh,
10.
but it doesn't look right. The is 5 is weird. What is 5 plus 10?
Yeah, because there needs to be a space.
Yeah.
My wife, Lisa, is big about grammatical spaces. Not 2 spaces,
Right.
but 1 space. That's
One
how you can read
space.
it.
It's gonna look better.
Let's hit it again.
Make Lisa happy.
Bazinga. Haha, what is 9 plus 5? 2 different numbers, and we got a space. All right. So that seems to work. And so what do we want to do? We want to check if that number, whatever the person entered, is actually correct. Whatever the user entered is correct.
Yeah.
So we are going to do a check. Binary logic.
Binary logic alert.
Wait,
binary logic.
Keep saying binary logic. Why do we call it binary logic?
Well, there's, yeah.
What's the origin?
The origin, I don't know. I guess binary, right, is zeros and ones, and so there's kind of 2 ways, a yes or no. So here it's like a if this, then that. So it's kind of like it's gonna ask you a question, and it's either gonna be true or not.
That's right. So binary basically means there's only 2 choices. It's either usually true or false, 0 or 1. Binary means there's only 2 choices, and in this case, it's either true or it's not true. So.
Right.
If it's true, it'll do what's in here. If it's not, it won't do what's in there. So that's why it's binary logic.
Yeah.
All right. So what are we checking against 50? Nothing. So when you do this ask in Scratch, it turns out that whatever the user enters, which is going to be entered right here, goes into this variable, a preset variable called answer. So we're going to stick answer in here, and we're basically going to check if it equals. We're doing a plus, so we're gonna check if these numbers, with whatever the person answered, is actually equal to number 1 plus number 2. So we use the plus operator. If it's equal to number variable, and you're using number 1 and number 2 as variables, put the plus operator in between. So if it is equal, what we want to do is we want to squish the curve down. Now, we haven't done this in our app streams yet, but what we want to do is actually talk to the curve. If the answer that we get from the line is correct, we want to tell the curve that the user got it correct, and the curve will go down a little bit. So what we're going to do is we're going to use broadcast. Wayne, what does broadcast do?
Broadcast is just like it sounds. You're going to yell out, hey, you're going to just broadcast it. You're going to yell it out, and whoever's listening is going to hopefully hear you.
That's right. Yell it out right now. Message 1.
Message 1. Number 2. I mean, not number 2. Anything but number 2.
Okay, we're going to call it something else, though, because we always want to name our everything something that we understand. So, meaningful, yes. So we're going to say right answer. So what we're going to broadcast is right answer. So if you get the right answer, we're going to broadcast right answer. So that curve.
Got it.
Yeah, so that curve can catch it and then do what it needs to do. Now, the one thing is that I'm just going to add in here real quick. You'll notice that we set these random numbers. We do one ask, and we check if it's right, and then it ends. But in fact, the way this game works is we want to keep doing that pretty much forever. Pretty much forever. So add in forever loop. Now then, it's going to ask these questions and keep asking questions. And if you get it right, it's going to broadcast the right answer. So if you get it wrong, then it'll just ask another question, right? That's what we want it to do. So back to the curve now. So now
we gotta make the curve listen to that. Be listening for that broadcast.
That's right, listening to that broadcast. Now, in Scratch, I don't think it's called a listener, but actually a listener is a technical term. There's a quick tech talk for you right there. A lot of languages out there has what's called a listener, and actually what it does is what we're gonna do here. It just sits and listens, kind of like you guys are doing right now at home.
Sort of, we're all listeners.
That's right. So when I receive, so this is basically their version of a listener. It's a starting block, and it basically means it's always sitting here listening and waiting for this right answer to be broadcast. Just like this one, the green flag, it's always sitting here waiting to listen for this green flag to be clicked. So it's essentially a listener.
It's almost like those 2 blocks kind of are within their own forever loop. in a way.
Kind of, yeah. Yeah, always listening, just kind of like this. Kind of like how
Yeah.
you guys are always listening to your parents, right?
That's right.
Right?
And if,
All right.
yeah, you better be.
That's right. All right, so when the ball receives right answer, we want it to just like clear everything and go down a notch, basically. Set your initial height down a notch. So what we're going to do here is, because this event here is actually separate from this, and what we actually want to do is talk to this event inside here. It gets a little bit tricky. So now the line has told this event that it's the right answer, and this answer needs to tell this loop here to clear your curve and go down a notch. So when I receive right answer, so broadcasting doesn't make as much sense here. What I'm going to do instead, because we're inside of this same sprite, I'm going to create a new variable, and I'm going to call it clear. I wouldn't say this is the most efficient way to do things. This is the first way I could think of doing Scratch. I don't know if I would do it this way in a normal language, but this is the best way I can think of doing Scratch. So what we're going to do is when I receive right answer, I'm just going to say set clear. Wait a minute. I'm going to make this screen bigger so you guys can see it. I'm just going to set clear to true. So what does that do? Right now, it doesn't do a thing.
Nothing, yeah. Just this weird variable is equal to true.
That's right. It doesn't do a thing. So what we're going to do is we actually have to check this is repeating until either it touches the edge, which means we're going to draw a new curve, or if we set clear, then it's going to stop this loop also and then go to the next loop. So what we need to do is check two things here instead of just this touching edge. We want to check. That's right. Or.
The or.
Or. That's another weird word.
Yeah, that is a really weird word.
Or join. Or join.
Yeah. Or join. I'm cracking up now, but I probably shouldn't be because I don't know. I don't know. Is that really funny? But it just sounds funny.
It sounds funny. Let's just say it. Or join.
I don't know. It's very odd. Very odd.
Okay, so we want to check if it's either touching the edge or we get a clear signal. So we just want to say if touching edge or it's clear. Wugga, 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 wugga. Clear is equal to true.
Clear is equal to true.
Yep. So if clear equals to true, it should also stop that arch from going and create the new one. But it'll basically still do the same one, right? But you know what? We haven't done it in a while, Wayne. We have not tested. We better run this.
Yeah, we better run it. Something could be broken. Probably.
This thing could be totally broken. Let's see what happens. I'm going to hit play. Broken. And oh, it's still going up. What is, I can't read it. What is 1 + 5?
5! 19!
Oh, so it just killed it. What happened?
It just killed it. There you go. And the initial height is still going up. Look at that. That's pretty cool.
Oh, initial height is going. Okay, so what does that mean? We need to mess with the code. Initial height divided by 2. Set height. Why is that?
Clear equal to true, and then this thing just stops, so this never repeats again. That's true, because clear is always true, so this is never going to repeat.
Bam! Nice. That's right. Clear is always equal to true. That's basically how you debug, right? You just kind of go.
Yeah.
and then you wait for Wayne to tell you the answer.
and then it will work, Something good will come of it. But you gotta have that face. You gotta have that face.
You gotta have the face. That's your debug face.
That is it.
If you don't have that face, you can't debug. All right, so we want to set clear back to false.
Yeah.
Down here. Set clear to
back to false.
False. Okay, right? So
yeah.
That happens.
Then it can run again.
What is 3 + 7?
10, 14, it's going too fast.
Oh. So it actually did work. It just like went too fast for me.
It went really fast. Yeah. It's
Yeah,
pretty
so
fast.
I think that worked. It cleared it. But what we want to do is it cleared it, but it actually drew the same arch again. So what we want to do is lower the arch a little bit so that we get a chance to lower it down, right?
Yeah.
So to do that, so we can do that in two places. I think we're just going to do it over here on the right side. It's a little bit clearer. We're going to set, oopsie, we're going to change our initial height by like -4.
Yeah.
So that means that once it
Lower it.
clears, the next time it goes around, it'll go down by 4, but because we have this here, it'll go up by 2. So net, it'll go down by 2. So hopefully when I run it this time, every time I get a right answer, it'll come down a little bit.
We got to get the right answers though. 18, 6.
We got to get the right answer.
12, 13.
Is it working? Is it working?
It's working. 10, 8.
Okay, so cool. So it's actually working.
13,
it's going down every time I hit it. So that's 15. What it's supposed to do. Yeah.
Yeah.
And if you guys are super smart, which I know you are, you can do multiplication if you want. You can do a number from 1 to 100 if you want, 1 to 1,000, although you would be total genius if you could run it with 1 to 1,000.
And still win.
Yeah, but since I'm not a genius, I can only do 1 to 10. Actually, I probably should have done like 1 to 3. Then I definitely would win.
Winner, winner, chicken dinner again.
Always the chicken dinner. That's right. Okay, so now the next thing we need to do is we just need to check if this thing hits the red line, then game over. We're just going to do a very simple thing here. So we're just going to check at the end of every loop if we are touching the
binary logic.
If the curve is touching the line, then we'll just tell it to stop. So stop all here under control.
Fair enough. Fair enough.
Let's see. All right, so I guess that works. That works.
That works.
Now let's just leave it until it goes up.
Let it go.
That's it.
One more.
Hey.
What happened? Is it going too fast to really touch it?
Okay, everybody, your debug face.
If it's touching that, yeah, does it not think it's touching that? Do we need to do touching the red color or something?
No, actually, it is something totally different. So, and I found this bug before. That's the only reason I know it so fast.
Oh,
so
I thought the face just worked again.
Well, it's also the face. It's also the face because we both did the face. That's
double the face always helps. Even faster.
When you get 2 people to do the face, you can always figure it out. Every single time.
That's why they have paired programming so that they can double the face. And people don't know that. That's
the origin behind the pair programming. Double face.
Yeah, to double the debug face.
All right, so the reason this isn't working is because what's happening here is this loop in here is actually doing drawing the arch, drawing the curve. Once it's done drawing the curve, then it's going to draw the next curve. But it's actually not checking while it's drawing the curve. It only checks it if it's once it's completely done with the curve. And it's not done with the curve until you're down here or way up here. So that's why it never hits this red. This is why it's really important to know the logic, kids. You could drag that stuff in there, but if you don't know why that works, then you can't really debug it other than using the debug face.
And you certainly can't tweak it or change it because you'd be very confused.
So now I put the if statement inside this repeat loop. So what that means is every time it goes up and over 1, it'll check whether it hits. So I'm thinking this should work. Let's try it. I'm not going to answer any questions, and let's see if it works.
But you do know, yeah. He's not going to answer. He does know the answer.
I do know.
It did it. It did it. It did it.
Yeah. Nice. So that is pretty much the game. There's a couple of things that I would probably change in it if we had some time. I don't know how long we've been running now, but
yeah, I don't know now, but I'll just hit stop.
Yeah. So I would probably change it to where, the curve should probably, be maybe a little bit smoother. You might want to have it smooth out at the bottom here. You might want to have the line go straight across. There's a number of things that you can do to make this curve prettier. The thing with the curve, guys, is it's not like cloning fun where we have all kinds of cats running around the place, but it is very logic oriented, right? It's very sort of math. My son keeps asking me, why do I need to know all this math? This is part of the reason, right? That when you know math, you can figure out the physics of things and how to make a ball move a certain way so it looks realistic. That way you can code video games and make them look realistic. Um, in fact, if we just had this as a ball, actually, I'll do it right now. This should be super easy to do. I'm just gonna take out the pen down stuff. And we are just gonna run this thing and just watch the ball real quick. Oh, the pen down is still going. Why is that? Oh, because the pen is down. Okay.
Yeah, because it's not
thought.
up.
Hold on to
Hold
that.
on. Pen up.
Erase all, and I'm just going to show you guys real quick. Pen up. So if we run this thing, look at the ball. Look at that. Doesn't that look like somebody's actually throwing that ball?
Yeah, that is pretty cool.
That's physics, baby.
Picture the arm right down there.
That's right. That's right. That's physics. That's just how physics actually works. And when you know the math behind it and can put it into your code, you can make it actually look like a real game. And in fact, next week, I think I already said already, we're gonna play around with more physics and how balls fly around, even coming at you and stuff like that. So that should be pretty cool too.
Yeah, math and physics and coding actually are very synergistic, and they go a lot, really well together. The more you know of either one of them, help you with the other subjects, and they all tie together in a lot of ways.
And that's why this stuff is so fun. I don't know about you guys. Wayne and I are total nerds, but we love solving puzzles. I don't know if you guys get those brain teaser books or whatever. That's what coding really is. Like, if I were to challenge you to make a curve like this and have it kind of flatten out on the other side, you really have to think through the logic of how to do it. And the best part is you don't need an answer key. The answer key is what the code actually does, right? If you can make the curve actually do that, then you got it right. And it really is a logic puzzle that's, for me, a lot of fun to do. That's why Scratch is so fun for me and Wayne. We like to use it all the time just because it's, we can solve some problems pretty easily.
Definitely. That is the best part about coding, is that you can see what it's doing, and that's your answer sheet. And so that's what I love about it. So when you got it, and it's just really satisfying when you do get it.
So I'll show you guys real quick also especially the intermediate folks, which you guys.
You know what I realized, Hansel?
Yeah. What's that?
One? The entire time, we never said, how we're supposed to say who we are more often and things like that. Hansel and Wayne, this is from the Coder School, AppStream, episode 3.
That's why you're watching.
Anyway, that's why you're watching it. And that's why.
Next time we'll just run a ticker at the bottom.
That's probably better. We'll code it up. We'll code up a ticker.
All right, check this out, guys. Here is Trinket, which is another one of our favorite platforms that we use. This is Python. This is actually, you can type Python into Trinket here and actually run it. And so here's some of the code here. You guys, if you really want to, you could pause and type it in if you'd like under trinket.io. I will run it for you guys real quick. And you can, let me see what that does.
No semicolons.
No semicolons. What does it do? It doesn't do anything. Who messed up my code? Who's been messing with my code?
Yeah. Why is that not running?
Hey. Okay. I'm gonna, let's see. I'm gonna see if I can reopen this Trinket. And if it doesn't work, well, sorry. It's just a live bug, I guess.
Yeah.
Why would that not be running? Draw, run, sleep time. Background size. Well, it should be running.
Yeah, that is
so you have to trust me on that.
Yeah.
Well, that's lame. Okay, all right. So okay. Well, so this is what Python looks like. I don't know. I must have hit something in here. I don't really have time to check why it's not running. But what I'll show you is. But you guys can see though. This is what Python looks like. This does very similar to what the other one did, but the curve is smoother. It does actually curve out and flatten out at the end. But this is the amount of code is in there. It's about the same amount of code, but you can see you have to type it all out, right? And if I miss this semicolon, I'm gonna take this thing out and I try to run it, it gives me an error, right? That's all it takes is a semicolon to really get it to not work, basically.
Yeah.
Now I'm kind of bummed that it doesn't work because I was gonna show you guys something cool, but I will go over here to JavaScript. This is the same thing.
This one better work now.
This one, if this doesn't work, then something is wrong with my code.
And again, that was good acting again on the Python one, because we just want to teach a lesson that when you're going to do like a live stream or something, be prepared.
Be prepared. Okay, so this, I think that works. So I'm going to slow that down for you guys. So you can see, guys, that, so this is called openprocessing.org. This uses JavaScript to run it. It uses JavaScript, but it also uses a separate thing called processing to help it draw on here. But I'll show you guys real quick that in JavaScript, it's about the same amount of code. It looks somewhat similar, but not really the same. Instead of colons, like Wayne says, we're going to do semicolons here. JavaScript has a lot of semicolons. Python doesn't. So it's pretty similar. But you can see if I run it, I don't know if you guys can see how slow it is.
Ooh.
You know, that curve is much smoother. You can see that at the end also it curves over, and then it kind of blows up. But you can see that, actually, I'm going to stop a curve. Let me see if I can stop a curve. So you can see that this curve kind of goes up slowly, and then it kind of goes down slowly, but it also just evens out here. Yeah. And this is just part of the code. This is how I coded it to kind of self-flatten. And so for you intermediate coders out there, that's one of your challenges. It actually took me a little bit to figure out how to do that. But once you do, it's like, hey, this awesome problem solved. I also want to show you that, Wayne mentioned earlier in our talk that JavaScript runs on the web, and so this is JavaScript. This is running directly on this web browser. And because it's meant to do that, it runs really fast. I actually have this sleep in here because that slows down every time I do the curve. Now, if I don't have this sleep in there, sleep just basically says, pause for 300 milliseconds. If I don't put it in there, what's going to happen is nothing.
Nothing.
It's that fast. JavaScript, because it's this JavaScript, it just draws it so fast that your eyes can't see it. I wish I could show you the Python version. Hey, there it is. What happened?
Hey,
it's really slow.
Maybe you just didn't have a sleep in there and it was too fast.
Maybe. Let me see. Let me see if this works.
It's all working.
Still not working. Yeah. I'm gonna say that's the server's fault, although that's probably not. Okay, anyway, so
blame it on the server. We could put on our debug faces, and then there is the blame it on the server.
That's right. There's a two ways.
Whenever you hit a bug, there's always a way around it.
You can always blame it on the server.
You can always blame it on the server, especially if your boss has got a deadline and it's still not working. Blame it on the server.
You guys can think about that in like 15 years when you have a job.
15 years. Just remember that nugget. Blame it on the server.
Yep, that's the one thing to remember. All right, guys, so sorry I couldn't show you the Python. I hope that JavaScript thing was interesting. If you're intermediate, again, go for it. You don't have to do it. You don't even have to do it in JavaScript or Python. For you intermediate coders, if you can get that curve to curve back down and not just fall straight down, get it to curve over. That's a big challenge. You can do it in Scratch because honestly, like Wayne says, the syntax doesn't matter. What really matters is understanding the logic and how the code works. Right. So what else do we got? I think that's it. I think that's it for AppStream 3. Call it a day. Go watch The Last Dance. We are recording this on Sunday.
The Last Dance.
We are excited to go watch Michael Jordan's Last Dance. Hope you guys stay healthy and are good. Happy coding, and we will see you next time.
Happy coding.